Alrighty, hey AP Chemistry. I wanted to make a quick beginning video for when you outline. I've made a couple of notes, just quick annotations in your text. And I'm going to jump over to page 251, I believe it was, where's the first annotation. So jumping over to 251, a couple of things that you need to know as soon as you walk back into class soon is energy of conservation, law of conservation of energy. Energy is neither created nor destroyed. This is page 251. And then units of energy are going to be big. Okay, so units, huge right here. So for conservation of energy, I could transfer energy between two systems, and it's the same total energy, but different systems can have a different amount of energy. That's going to be big for this chapter. The unit of energy that we use is the joule. The joule comes from a kilogram times meters squared per second squared. On the previous page on 251, it used the equation kinetic energy equals 1/2 mv squared. That's energy. That's an equation you may have seen in middle school or before. Kinetic energy calculations like that are not going to be big yet. We can do some calculations, but I wanted to focus more on heat and work. So the joule is the big unit of energy. It's a kilogram times meters squared per second squared. And here are some conversions. 1 calorie is 4.184 joules. A kilocalorie is 1,000 calories, or 4,184 joules. And then they have like a kilowatt hour is 3.60 times 10 to the 6 joule. What's going to be big is the calorie. Okay. And then skipping over to page 255. Okay, understanding the flow of energy, system into surroundings. If I have energy that goes from my system to my surroundings, that means that energy is leaving the system, and we're going to call that an exothermic reaction. If I have energy coming from the surroundings to the system, my total energy is going to be positive. I'm gaining energy, and we're going to call that an endothermic reaction. We'll talk about those terms later. This is going to be big. These are two terms that are big. The system is the thing that we're studying, and you'll read about that. And the surroundings is everything around my system. So understanding the flow of energy and understanding those sign conventions is going to be very important on page 255. And then over to 256. Okay, and I wrote a note here. This is going to be big for quick check number 1, using this equation delta E, which is the total internal energy of the system, or the change in the energy in the system. It's Q plus W, where Q is heat and W is work. Okay, and heat and work could go into and out of the system interchangeably. And so there are some sign conventions here about positive and negative. Again, if I'm losing heat, or energy is leaving the system in the form of heat, that's negative. If I'm gaining heat, energy is coming into the system in the form of heat, that's positive. Just reading through the table 6.3. And then again, representing how energy between the system and the surroundings works. Delta E of the system is equal to negative delta E of the surroundings. So whatever happened to my system, the opposite happens to my surroundings. And then I'm going to jump on over to page 259. This is going to be big still for quick check 1 and 2. Q equals C delta T, and specifically Q is equal to MC delta T. This is an equation that might look familiar from honors chemistry if you've taken it. There's going to be a big equation that I use to calculate energy associated with changes in temperatures. So M is my mass in grams, Q is my energy or heat energy in joules, C is known as specific heat capacity. Those are constants. Okay, they are a given, or sometimes you have to figure it out given other information. And delta T is a change in temperature. And you'll read and see that delta T is final temperature minus initial temperature. And so I wrote a note here that for example 6.2, this is helpful for quick check 1B, right? Doing an example like this, making sure you know and read through this example, that's going to help you with quick check 1B. And then I made a note here for example 6.3 on page 261. This is also helpful for quick check 1B. It talks about calculating final temperature, and one of the questions in quick check 1B is, what is the final temperature? So walking through this problem is going to be helpful for that. For right now, we're skipping work, pressure, volume work, so that's not really going to show up in your quick checks. We're also going to skip the measuring delta E for chemical reactions at constant volume calorimetry. That's not going to show up too much in your quick checks. We will go over this in class, but it's not going to show up over this winter break assignment. It's good understanding, like it's a good question. Example 6.5 is a great question to look at, but it's not going to be something on your quick checks. And then over here to 6.6, quick check 1, kind of understanding what delta H is and where it comes in, and how things are endothermic and exothermic reactions. So again, here's my definition for endothermic, right? What delta H is. And here's my definition for exothermic with respect to delta H. So make sure you know that in this chapter. This is on page 268. And then also looking at these processes and knowing whether or not delta H is going to be positive or negative, going to be super important. And then jumping over to page 269, this is going to also be helpful for quick check 1b. In quick check 1b, it gives you the delta H for a phase change, but it gives it to you in kilojoules or joules per mole. Using stoichiometry or relating how many moles to grams and grams and moles to joules, that's going to help you answer that question. Same idea for example 6.7. This is going to be helpful for quick check 4. Going through this problem definitely looks very similar in the works of quick check number 4, so you can make a note of that for yourself here. And then section 6.8 in relationships involving delta H, also for quick check 4, where it talks about what we could do with delta H and how we could get different amounts of delta H. We're not going to do too much Hess's law. Hess's law is not going to show up in your quick checks, but understanding how to rearrange, this is going to be the most important one for quick check number 4, and that's what we're going to end with. Determining enthalpies from standard enthalpies. This is huge for quick check number 4. Understanding how I could use standard enthalpies, we'll call them, delta H's, to figure out the delta H of a reaction. That's going to show up in one of your last questions of quick check number 4. Okay, so kind of walking through the important parts of your text right now. I zoomed in on very important parts, so everything that I mentioned in this quick video, make sure that you have outlined in your notebook or outlined for chapter 6. These are going to be helpful for your quick checks and what I expect you to know